Welcome to the Deep Dive.
Great to be here.
Today is May 10th, 2025, and we're doing one of our focus dives, zeroing in on three big developments in tech right now.
Yeah, think of this as your quick briefing on what you really need to know. We've gone through the news, the research reports.
Exactly, to pull out the key stuff for you. So what's on the docket?
Okay, we've got three main stories. First, Cisco's making moves in quantum networking. Then, Boston Dynamics Atlas robot. It's actually going to work in a factory.
Wow, okay.
Yeah. And finally, a really significant step forward from MIT towards fault-tolerant quantum computing.
So quantum networking, robotics, quantum computing advances, lots to cover.
Definitely. And we're pulling from sources like Reuters, MIT News.
Yeah.
Good, solid stuff. The goal is just to give you a clear picture, the essential insight.
All right, let's jump in. Story one, Cisco. They've unveiled a new prototype chip.
That's right, a chip specifically designed for quantum networking. And they're not just talking theory, they've opened a new quantum computing lab, too, down in Santa Monica.
Okay, so networking quantum computers. How does this chip actually work?
Well, the core idea is pretty neat. It uses entangled photons.
Ah, the spooky action stuff.
Exactly, that uncanny link. It uses those photons to connect smaller individual quantum computers together.
So it's like building blocks, linking them up.
Precisely. Think of it as the early plumbing for a future where quantum processors can work together, scale up much bigger than they can now.
It's not just about one super powerful quantum computer then, it's about connecting them.
Right. It's architecting a whole new way of doing distributed computing, but, quantum.
Okay, that long-term vision is huge. But you mentioned near-term applications too.
Yeah, and this is interesting because it's not just about linking quantum computers yet. They're looking at things like ultra-precise time synchronization.
Which matters for?
High-frequency financial trading, for one, where, nanoseconds can mean big money.
Right, okay, makes sense.
And kind of unexpectedly, they're exploring using it to make meteorite detection systems more accurate.
Meteorite detection. Okay, didn't see that coming.
Me neither. It shows the breadth of where this precision timing could be useful.
And they're working with university researchers on this.
Yep, collaborating with UC Santa Barbara. Their bigger goal, the stated one, is building a large-scale quantum network.
So beyond just linking a few machines in a lab, we're talking quantum internet potential.
That's the ultimate vision, yeah. Something with fundamentally more secure communication, maybe distributed quantum computing power across many nodes, think secure global transactions, massive scientific simulations run collaboratively.
Okay, the potential is really staggering.
It is. And for anyone wanting the technical nitty-gritty on the chip or the new lab, that Reuters article has a good breakdown. We'll link it for you.
Perfect. Okay, let's pivot from a quantum realm to something a bit more physical.
Robots.
Yes, let's talk Atlas. Boston Dynamics humanoid robot. Big news here.
I feel like I've seen videos of Atlas for years doing backflips and parkour. We all have, but this is different. It's actually being deployed commercially at a Hyundai manufacturing plant in the U.S.
Whoa. So not just a demo. It's actually going to be like on the factory floor.
Yeah, the first time, yes. In a real working factory environment, it's moving beyond the lab demos and the cool videos into actual industrial tasks.
That feels like a massive step for humanoid robotics.
It really is. It'll be working alongside other robots Hyundai already uses, like Spot, the dog-like one, and Stretch, which moves boxes.
But Atlas is different because it's humanoid.
Exactly. Its advantage is that human-like form and mobility.
Yeah.
It gives it a dexterity and adaptability that, a typical fixed industrial robot arm just doesn't have.
So it can potentially do things on an assembly line that maybe only humans could do before, or navigate spaces designed for people.
That seems to be the idea. Tasks requiring more complex manipulation, maybe in tighter spaces, or interacting with workstations designed for humans.
So what does this deployment signal for, like, the future of factory automation?
Well, it suggests a possible shift, doesn't it? Maybe moving towards robots that aren't just single-task machines bolted to the floor, but more versatile mobile agents almost.
Able to handle a wider range of jobs.
Yeah.
Interact more flexibly.
Potentially. It definitely makes you think about how factory workflows might change, how humans and these advanced robots might work together or not.
Yeah, and the practical challenges must be huge too, right? Keeping it running, maintenance, adapting to unexpected stuff on the line.
Oh, absolutely. How does it handle wear and tear? What happens when something goes wrong? These are big questions moving from controlled demos to the messy reality of a factory.
There's probably a video of this.
There is. Reuters has video reports showing Atlas in this new setting. Worth watching. We'll link that too.
Great. Okay, so we've gone from quantum networks to robots on the factory floor. Our third story takes us back to the quantum world, but focusing on the computing side, MIT.
That's right. MIT engineers have made a significant breakthrough. It's about getting closer to actually useful quantum computers.
Useful meaning, reliable, able to solve real problems.
Exactly. Practical, and the key term here is fault tolerant.
Okay, and what's the breakthrough specifically?
They've developed a new type of superconducting circuit. And the big deal is it can speed up quantum operations, potentially by up to 10 times.
Tenfold. That sounds like a massive leap.
In quantum computing terms, it absolutely is. Speeding things up is critical.
How did they manage that? What's the innovation?
So the core of it is creating really, really strong nonlinear interactions between photons, light particles again, and the qubits.
Qubits being the quantum version of computer bits.
Right. By making these interactions between light and the qubits super strong, they can manipulate the quantum states much faster and with more control.
And why is making it faster so important for getting to this fault-tolerant stage?
Because current quantum computers are incredibly fragile. They're easily disturbed by noise, by vibrations, heat, anything really. This causes errors, lots of errors.
Which limits what they can actually calculate reliably.
Severely limits them. To build a truly useful quantum computer, you need error correction. You need ways to detect and fix these errors as they happen.
Okay.
And robust error correction schemes generally require you to perform many quantum operations very quickly. So by speeding up the fundamental operations by tenfold, like MIT has shown.
It makes implementing that crucial error correction much more feasible.
Exactly. It's a vital step on the path. It brings practical, fault-tolerant quantum computers, ones that can actually tackle big, complex problems closer to reality.
It really feels like we're moving beyond just theoretical possibilities now. These are concrete hardware advancements.
It does feel that way. The progress is becoming more tangible. And if you want the deep science on this, the full report on MIT News goes into all the physics.
Yep.
We'll provide that link as well.
Excellent. So let's recap the three areas we hit today.
Okay. We started with Cisco's work on quantum networking, that prototype chip, the new lab, the potential for a quantum internet down the line.
Right. Then we shifted to Boston Dynamics Atlas, the humanoid robot, stepping out of demos and into a real Hyundai factory. A big moment for robotics in industry.
Definitely. And finally, that MIT breakthrough with the superconducting circuit speeding up quantum operations significantly, which is really crucial for building fault-tolerant quantum computers.
It's fascinating how these different threads, networking, robotics, fundamental computing, are all advancing. You start to wonder about the overlaps, right?
Absolutely. You think about a future with robust quantum networks, adaptable humanoid robots, and powerful error-corrected quantum computers. What happens when those things start to connect and interact?
Yeah, what kind of entirely new technologies or applications could emerge from that convergence? Things we probably can't even really imagine properly yet.
It does make you think. These developments could lay the groundwork for some truly transformative changes.
So maybe a final thought for everyone listening. As you heard about these advancements, what connections did you make?
Yeah, how might these things, faster quantum processing network systems, more capable robots, ripple out? How could they impact different industries or even, aspects of daily life or work in the coming years?
What possibilities get you excited? Or maybe what challenges do you foresee?
It's definitely a space to watch. We're seeing some really pivotal stuff happening right now.